Hello everyone, welcome to Ramanujam School of Studies Beat the Good, Be Great. Right? In this channel, we discuss about the basic concept of mathematics from class 9th up to class 12th, and we also discuss about the basic concept of class 11th physics. Now, today lecture is class 11th arithmetic progression, and this is the lecture 3, and today I will do question on sum of AP, and this is the part 1. In previous class, we already discussed about the basic concept of progression, arithmetic progression, and we derived different formula, that is Tn, Sn, and we also did the work on the formula Tn. Now today we will do work on the formula Sn, right? So moving to the first question, we have find the sum of series. Now here we have the given a series. The difference between series and sequence is that sequence separates by comma and series have a plus or minus sign between the two terms. Now here we have to find the sum of series. So sum of series can be written as Sn, and here the series is 50 plus 46 plus 42 plus up to 10. Right? Now as we know that Sn is equal to n by 2, where n is the number of terms of the series, into 2a, that is a is the first term of the series, plus n minus 1 into d, that is d. Here d is the common difference. Now in this series we have d, this is equal to 46 minus 50 or 42 minus 46, so d is equal to minus 4, and a is equal to 50. The first term is 50. Now here we have to find the value of n, and in this series we see that the last term is 10, so we can apply the formula last term or Tn. This is equal to a plus n minus 1 into d. Okay, now the last term here is 10, so we have 10 is equal to a, this is equal to 50 plus n, and we have to find the value of n minus 1 into d is equal to minus 4. On calculation, we can write here 10 minus 50 divided by minus 4. So here we can write minus 40. This is equal to n minus 1 minus 4, right? So from here we can write n minus 1 is equal to 10 and n is equal to 1. So we get the value of n is equal to 11. So we get the value of total number of terms of the given series. Now we have to find the sum of the series. So as n, here we put the value of all the value variable, that is n, d and a, in order to find the value of series, sum of series. So we put n is equal to 11 divide by 2 into 2a. 2 is the factor which is multiplied by a, and a is 50, so this is 100. Okay, plus n minus 1, n is 11 minus 1 is 10, and this d is equal to minus 4. We gather all the information from the question and we put all the values here. So we can write here 11 divide by 2 into 100 minus 40, that is 60. So this is cancelled out and we have 11 multiplied by 33. So if we multiply the both term, we get the value 11 multiplied by 30. This is 30. So we get the value 330. So in this question, we apply the last term in order to find the number of term of the given series, and then we apply the formula of sum of series, that is Sn is equal to n by 2 into 2a plus n minus 1 into d, and step by step calculation we get the value of sum. So this question is very easy, and this question asks in low level engineering examination as well as different type of board examination. So, and also this question cleared the basic concept of series. Now moving to the next question, find the sum of all even number from 101 to 999. So we have to find the sum. Sum means Sn, and here again we have Sn is equal to n by 2 into a plus n minus 1 into d. Now here we have the series, that is sum of all even number from 101 to 999. So the first even number of the series must be equal to 102, the second is 104, and the last is 998. So here we have the value of A, and the value of A is 102. We have the value of D, and the value of D is 2, being the even number, and even number separates themselves by 2, that is 2 consecutive even number. Difference between the 2 consecutive even number is 2, and here we have to find the value of n. So here we apply the formula last term. This is equal to A plus n minus 1 into D, as we did in the previous slide. So we have L is 998, A is equal to 102, this is 102. So here we write 102, right? So plus n, we have to find the value of n, and D is equal to 2. So 998 minus 102, that is 896 minus 2, 8 minus 6, this is equal to 9 n minus 1 into 2. So n minus 1, this is equal to, if we divide 896 divided by 2, we have 448 and 448. So here, from here we get value n is equal to 449. Now we get the value of n is equal to 449. So we can put the value of this 449 in the given formula, that is 449 divided by 2 into 2 into 102, that is 104, plus n minus 1. We have n is equal to 449, so we can write here 449 minus 1, and the value of D is 2. So if we take this is 2 into A, and A is 102. So if we multiply 102 multiply by 2, we have 202. So 449 divided by 2, this is equal to 204 multiplied by 4, this is plus 448 multiplied by 2. Okay, now we have 449 divided by 2 multiplied by 1, this is 1000. 204 plus 896, and this is 449 divided by 2 multiplied by 1000. Now if we multiply all the factor here, we have value 246,950. So this is the answer of the given question. That is, we can find by using last term and by using Sn, n is equal to 1 by 2, n by 2 into 2a plus n minus 1 into d, we get the value of summation of the given series. So applying the same concept as the previous, we find the solution. Now moving to the next question, we have find the sum of all positive integer less than 200 that are divisible by 3 and 5. Now see here, we have to find the sum of all positive integer less than 200. So if we write sum of all positive integer 1, 2, 3, 4, okay, 5, 6, 7, 8, 9 and up to 15 and 30. Now so on, we see here we have a different natural number, right? Now the integer are divisible by 3 and 5. See here, 3 and 6 and 9 are the integer which is divisible by only 3, and 15, 30 are the integer which are divisible by both, that is 3 and 5. And also we have 3 and 5, okay, and 5 are co-prime numbers, so their LCM or multiplication must be divided by, that is their multiple 3 and 5, multiple of 3 and 5 must be divided by both 3 and 5. So series is 15, the first term of the series, that is integer which is divisible by 3 and 5 is 15, plus 30 plus 45 and up to the last term here is less than 200. So the last term here is 195, which is divisible by both 3 and 5. Okay, now we have the find sum as n. So in this question we have to first form series as the, and here we use the property of prime number. Okay, now here a is equal to, we have a is equal to 15 and d is equal to again 15, and we have to find the value of n, right? N is, now as we did in the previous slide, in order to find a, in order to find n, we have L is equal to a plus n minus 1 into d. So L is 195, a is 15, plus we have to find the value of n, so n minus 1 into d is equal to 15. So further we can write 1915 minus 15, this is equal to 180. This is n minus 1 into d is equal to 15. So n minus 1 is equal to 180 divided by 15. This is equal to 12. So n is equal to 13. Okay. So we get the value of n, which is equal to 13. Okay. Now sum Sn is equal to 13 over 2 into 2a, that is 2 into a, that is 2 multiplied by 15, this is equal to 30, plus n, that is 13 minus 1 into d, and the value of d is 15. Okay. Now when we calculate it, we have 13 over 2 multiplied by 30 plus this is equal to 12 multiplied by 15. So here we can write 30 plus 12 multiplied by 15. Now overall calculation we get value 1365. So this is the answer of the given question. Now moving to the next one. The next one is similar to this one, and the question is the sum of all positive integer less than 200 that are divisible by 3 but not 5. Now here we have in the series we have some common term which are divisible by 3 and also by 5, and we find the sum of such number which is divisible by both, that is 1365. Now here we have to find the sum of all positive integer which is divisible by 3. So series which is divisible by 3 is 3 plus 9, 3 plus 6 plus 9 up to how much, that is 12 up to 198. So sum, if here we find sum which is divisible by 3, so Sn is equal to again n by 2 into 2a plus n minus 1 into d. Right now using last term, that is L is equal to a plus n minus 1 into d. So L is equal to 198 and a is equal to 3, plus here we have to find the value of n, and the value of d is common difference, this is 3. So this is 195 divided by 3 into n minus 1. This is equal to n minus 1 because here 3 is divide 195 and n minus 1. This is equal to if we divide it, we get 65 and n is equal to 66. So we get the value of n is equal to 66. Putting these all the values, 66 divided by 2 into a is equal to 3 plus n minus 1, where we have n is 66 minus 1 and d is equal to 3. So we get the value 66 divided by 3, that is this is equal to 33, and 6 plus 65 multiplied by 3, that is 195. Okay, and the value when we calculate it, we get 663. Okay, 6633. Now here we have to find the number, the integer which is divisible by 3 but not 5. Now here we see that there are some term which is common, which is multiple of 3 and 5 as well. So that is 15, 30 and 45. So we have to subtract that series, that, and we get the value of that series is 1365 in this question. So we have S is equal to 6633 minus, here in the previous question we get the value of that series, that is 1365. So here we put the value of 1365 and finally we get the final answer, and this is equal to 5268. This is very good question, and this question frequently asked in board examination. So make practice on this question. Now moving to the next one, we have how many terms of 1 plus 3 plus 5 plus 7 up to amount 1, 2, 3, 4, 3 to 1. Now here we have the given series and the sum of series. So Sn is given, that is 1 plus 3 plus 5 plus 7, and this Sn is equal to 1, 2, 3, 4, 3, 2, 1, and here we have to find the number of terms. So here Sn is equal to this, so we have Sn is equal to n over 2 into 2a plus n minus 1 into d, and this is equal to 1 2 3 4 3 2 1. Okay, now here we have to find the value of n, so n is such that so n by 2 into 2 into a, so 2 into 1, the value of a is 1 plus n, here we have to find the value of n into n minus 1, and the d is the common difference in the given series, that is 3 minus 1 or 5 minus 3, that is 2. So here we will write the value of 2, so this is equal to 1 2 3 4 3 2 1. So we can write here n by 2 into 2 plus 2n minus 2. So here again we have 1 2 3 4 3 2 1. So 2 and 2 is cancel out, so we have n divided by 2 into 2n. Again here 2 and 2 is cancel out, and this is equal to n square. So we can write here 1 2 3 4 3 2 1. So this is equal to n square. So n is equal to square root of 1 2 3 4 3 2 1, and when we square root of the given number, we get n is equal to 1 1 1 1. So total number of term in this question is 1 4 1 1 1 1, right? So this is also important question, make practice. Now moving to the next one. The question is the nth term of an AP is 3n minus 1. So here it is given Tn, and this is equal to 3n minus 1. So we can find T1, and T1 is, we have put the value of n is equal to 1, so 3 minus 1, that is 2. T2, that is 6 minus 1, that is 5. T3, that is 9 minus 1, that is 8. Okay. T4, that is 12 minus 1, that is 13. So we get the value of Tn if we put the value of different value of n, and we get the series 2. Okay, we have the sequence 2 comma 5 comma 8 comma 13. Okay, 8 and this is 11 here, because if we put the value of n is equal to 4, we have 12 minus 1, that is 11, and so on. So this is the series sequence. Now here we have to find the sum of series up to p term. So SP, this is equal to p over 2, no doubt, into 2 into a is 2, so 4 plus n minus 1, so n is equal to here p minus 1 into d is equal to the common difference between the consecutive term, that is 5 minus 2, that is 3. So here we write 3, and SP is equal to p over 2 into 4 plus 3 p minus 3, and we get the value p by 2 into 3p plus 1. So in this question, SP is equal to p by 2 into 3p plus 1. So if we have the value of Tn in terms of n, so we, by putting n is equal to different value 1 2 3 4, we get the desired sequence or series, right? So in this question, first we have to find the series, and then we have to find the sum of the given series using the sum formula. Okay, now moving to the next one. The next one is the first term of an AP is 17. So here a is given 17. The common difference is, we can write here, common difference is minus 2, and sum of Sn is given 72. Find the value of n, explain the double answer. Now here Sn is equal to 72, and we can write Sn is equal to n by 2. So here we have to find the value of n, so we can write n by 2 into 2a. 2 into a is 17, so we can write here 17 plus 2a into n minus 1 into d, n minus 1, and the d is minus 2. So this is the overall equation. So we can write here 72 multiply by 2, that is 72 multiply by 2, this is equal to n into 34 minus 2n. Okay, plus 2, right? Because if we multiply minus 2 with n, we have minus 2n plus 2. Now solving this, we have 144 and n in, and this is equal to 36 minus 2n, and we get a quadratic equation here. that is 2n square. If we take common, we can write here 72 is equal to n into 18 minus n, as we have take 2 as a common and we cancel out the common factor. So we have n square, we can write here n square, and we can write here 72 is equal to 18n minus n square, and further we can write n square minus 18n, okay, plus 72, this is equal to 0. So further we split the middle term, so we can write n square minus 12n, okay, minus 6n plus 72 is equal to 0, and if we take common n in this, we have factor n minus 12 into n minus 6. So we have two values and this is equal to 0. So we have two values, that is n is equal to 12. Here we can write n is equal to 12 and n is equal to 6, right? So this is the answer of the given question. Now what here we have to explain the double answer. Now when we make a series, the first 6 term, that is Sn, is equal to 72. Now if we further move due to the common difference negative, it as series form, we get the first 12 term, the sum of first 12 term is also equal to the sum of first 6 term. So both answer are correct, and you have to make the series by using the given information and add up and up to 6 term and up to 12 term and see what happens. So this is your homework. Now moving to the next one. This is very good question, very good question, and this question asks in many engineering examination this type of question, not exactly this question. So the sum of Sn, here Sn is given, this is equal to 2n square plus 3n, and it is asking about is the series is arithmetic, and if so, find it. Now the arithmetic series means tn minus 1, this must be constant for the arithmetic series, as we discussed in the previous class. Now tn is nothing, tn is Sn minus 1 for all the series. So we have Sn is equal to 2n square plus 3n, this is Sn, and if we subtract Sn minus 1, that is 2n minus 1 square, okay, plus 3n, we get tn. Now expanding this one, we can write 2n square plus 3n minus 2 into n square plus 1 minus 2n plus 3n, right? So we have Sn here 2n square plus 3n minus, we have 2n square, okay, minus 2 and plus 4n and minus 3n, and here minus 3 and minus 3 and 2n square is cancel out with 2n square, 3n square is cancel out with 3n square, and we get the value of tn, and this is equal to 4n minus 2. Now we have to find the value of tn minus 1, so that if we got the value constant, the series is arithmetic. So tn is this one, tn minus 1 is 4n minus 1 minus 2, and if we subtract tn minus 1, so we have 4n minus 2 minus 4n minus plus 4n minus plus 2. So this is cancel out and this is again cancel out. So we have tn minus 1, this is equal to how much? 4, and this is constant. So here we see that the tn minus 1 is a constant quantity, so the given series is arithmetic, and we have we prove here the given series is arithmetic progression. And if we put Sn tn here, what is the tn? Tn is 4n, here tn is equal to 4n minus 2. So in order to find the series, we have to put t1, this is equal to 4 minus 2, that is 2, t2, that is 8 minus 2, that is 6, t3, that is 12 minus 2, that is 10. So similarly here we see that 2 plus 4, that is 6, 6 plus 4 is 10. So this is the series though. So final series is 2, 6, 10 and 14. So this is the series, and the given expression if sum is this, so the series is an arithmetic. So this is a very important question, and this type of question is asked in very good engineering examination. And this formula is very important. Sn is equal to this one, Sn Tn is equal to Sn minus 1. So this is important. Now moving to the next question, the sum of p term of NAP is q and the sum of q term is p. So prove that sum of p plus q term is minus p plus q. So this is for your homework. You should do it in very good manner. Okay, now for this for today this is enough. So if you like this video, and if you understand the basic concept of arithmetic progression, and if you are now able to solve the problem, please share, like and subscribe my channel. Have a good day. Jai Hind.